All right, guys, lesson 98, relations and functions. So this lesson really could be broken down to this question. Is the graph a function? Okay, and so we can figure that out today a couple different ways. All right, so let's go through a couple notes real quick. Okay, so first, let's define what a relation is. And it might be easiest if I just give you some examples, but a relation is a pairing of two sets of information. Okay, so simple as that, a pairing of two sets of information. So some examples, right? An example would be a phone book. Kind of a thing of the past, right? But a phone book pairs two sets of information. People's names with their phone numbers, right? So the two pieces are names and phone numbers. Right? Another example, a sports roster, right? It pairs the names of the players with their jersey numbers. Okay? Some other examples, right? A soda machine. So we used the soda machine before when we were talking about functions. It pairs the button and the label, right, on the outside with the can that comes out, okay? So a couple examples of relations, right? So the pairing of two sets of information are going to be given to us in three ways. So if I go back up here, all right, given three ways. Okay, so the first way is in set notation, right? So we can be given a pair in set notation. All right, the second way is going to be in a table of pairs. So think input-output table. Okay, or the third way, a graph. All right. All right. So your practice set, if you look for this lesson, has 4 questions, and the 4 questions are simple. Simply, is this a function? So they're going to give you some relationship or a relation or a graph, and they're going to ask you, is this a function? Okay. So let's look at what we can do to determine if something is a function. All right. So here's the first example. All right. Example number 1. I am told that I'm trying to figure out how much it will cost me to buy a certain number of tickets to go to a sporting event, go to a Capitals game, all right? So I know that if I'm trying to figure out how many of my friends can I take, all right? I only have so much money, and I'm trying to figure out which of my friends are not gonna be getting the invite, right? All right, so I'm gonna make this input-output table, and so I know that if I buy 0 tickets, it's going to cost me $0. If I buy 1 ticket, it's going to cost me $5. If these are Caps game tickets, these must be coronavirus prices or nosebleed section, right? 2 tickets is going to cost me $10. 3 tickets is going to cost me $15. and 4 tickets is going to cost me $20. All right, so here is a table, an input-output table. All right, so let's go ahead and just graph it real quick. So we make our X and Y axis. I'm only doing this quadrant because I know that it's always going to be positive. All right, and so we'll say that my Y, my X axis, my input is the number of tickets. And my Y axis, my output is the price. All right, so we'll just go ahead, give some. All right, so say 1, 2, 3, 4, 5, and we'll go by 5s over here. 5, 10, 15, 20. All right. So if I buy 0 tickets, it costs me $0. So there's that point. If I buy 1 ticket, it costs me $5. 2 tickets, $10. 3 tickets, $15. 4 tickets, $20. And I could continue going on here, right? And so we could come up with the equation for this. That is, the price, P, is going to equal $5 times the number of tickets. All right, so there's our equation. And we might be asked, is this a function? Is this a function? So here's the first way that we determine if something is a function or not. And you may remember this. So if for each input I have only one output, it is a function. Okay? For each input, if I only have one output, it is a function. So you remember this, hopefully, from when we talked about functions previously, and I gave the example of the soda machine, right? Where every time I press a Coke button, I get a Coke out. It's a function, right? If every time I press the button and I get what's on that button out, it's a function. If, for whatever reason, I go up to a soda machine and hit the Coke button, and 50% of the time I get a Coke, and the other 50% of the time I get a Sprite, not a function. If I don't know what I'm getting out of the soda machine, it's not a function. But if every time I know exactly what I'm going to get out, then it is. Even, let's say, I hit the Coke and I know I'm getting a Sprite every time, that's a function, right? Because I have one output. Every time I hit Coke, I get a Sprite, function. Every time I hit Coke, I get a Coke, function. Every time I hit Coke, I get either a Coke or a Sprite, not a function. All right? So here's your first test. If every time I have an input, I only have one output, then it's a function. So as we look back to this example, for each input, 1, 2, 3, 4, or 5, there is only one output. I'm never going to buy one ticket and have it cost me, sometime it might cost me $5, sometime it might cost me $50. That's not happening here, right? Every time I buy one ticket, it costs $5. 2 tickets, $10, right? So then, therefore, I have a function. So yes is the answer to this first example. And that introduces the one input, one output function idea, all right? Here we go. Next, let's take a look at another situation. So this one's a little bit more unique, okay? So we're talking about how many students, so let's think about when you guys come to school in the morning, how many students there are waiting outside the door before 8 a.m. from 7:30 to 8 a.m. Okay, so at 7:30 you show up, how many students there are, then you show up at 7:35, how many students there are, 7:40, 7:45, 7:50, 7:55, 8 o'clock. So let's take a look at that, okay? So we have our input, which is gonna be minutes before school starts. All right, and our output is going to be the number of students at the door. Okay, so we'll make a table. So if I show up 1 minute, so the first day I did this study, I showed up 1 minute before school starts, 7:59, before those doors opened, and there were 25 students already there, waiting at the door. So 1 minute before school starts, 25 students waiting at the door. Then on Tuesday, I show up 10 minutes before school starts, so 7:50. And there were only 10 students waiting outside this time. On Wednesday, I show up, I get there real early, 30 minutes before school starts. Maybe Mr. David's got a review session that morning. So 30 minutes before school starts, weird. Only 2 students were there that day. On Thursday, I show up 10 minutes before school starts again, so 7:50. And this time, there were 15 students waiting at the door. All right. And let's say I show up 20 minutes before school starts, okay? And there were 5 students. So Monday I show up 1 minute, Tuesday 10 minutes before, Wednesday 30 minutes before, Thursday 10 minutes before, Friday 20 minutes before. And these are the number of students waiting each of those days. So let's graph. Make our X and Y axis. Here's Y to the sky, X, all right, and let's label them. So the input is minutes before school, so I'll just say minutes. And the output is number of students, so we'll just say students. So let's graph, all right? So my first input is 1. All right, so minutes before school starts. So we'll go by, let's see, we'll go by 5s here. So 5, 10, 15, 20, 25, 30. All right, and we'll go by 5 on the other side as well. All right, so 5, 10, 15, 20, 25, 30. Okay, so here we go. Let's chart our input and outputs pairs. So 1, 25. So 1 would be real close here to 0. So I'll go 1, and there's 25 students. So we'll say that's right about there. All right. When I show up 10 minutes before school starts, there's 10. So 10 minutes before school starts, 10. That's there. 30 minutes before school starts, there's only 2 students. It's going to be like right there. 10 minutes before school starts, again, 15 students. And then 20 minutes, there are 5. Okay. So there's my data plotted on the chart, on the graph, right? And I am going to ask now, is this a function? So far, we know that a function is only a function if for each input there is one output. So we're really asking for every input, for each input, every one input, is there only one output? Okay? So the answer here is no. And the reason being, for 10, the input 10, I get two outputs. There are 2 points. So I don't know. If I hit 10 on the soda machine, do I get a 10 out or a 15 out? I don't know, right? There are 2 options, okay? So since I showed up 10 minutes before school starts and one day there were 10 students waiting and the other day there were 15 students waiting, this is not a function. And the reason being, for the one input 10, I have 2 outputs. And those are 10 and 15. So the answer is no, not a function, okay? Because I have 2 outputs for 1 input. All right. So then the next thing is this idea of a vertical line test. Sorry about that. All right. So we can also use a vertical line test. All right, or the VLT. All right. And the vertical line test is just this. If a vertical line can be drawn through a graph and passes through more than one point on the graph, then it is not a function. Okay, sorry, that took a little while to write. All right, so if a vertical line can be drawn through a graph and passes through more than one point on the graph, then it is not a function. All right, so we'll do a couple examples, but let's just go back to the 2 graphs we've done before. Okay, so if I draw a line connecting through these, if I were to graph this, okay, so we'll go back here to green. Let's go with this. All right, so we're going back here, and we're drawing a line through here. All right, so here's my graph, okay? And then I'll use black, right, to test. So we're gonna do the vertical line test. If I draw a vertical line through this graph, and it passes through more than one point, it's not a function. So do any of these black vertical lines pass through more than one point? No, they intersect each of these vertical lines intersects only in one spot with the green line. So therefore it is a function. This will be clearer here. All right, so let's go ahead and make a best fit line for this one. So we're already set up. So if I were to graph this, it would look probably something, kind of like this. There, right? It's not going to fit perfectly due to the graph. All right, so let's do the vertical line test. So we'll go red this time. So I'm going to draw vertical lines and see if there is anywhere where my vertical line intersects two spots. All right, there it intersects two places, so therefore not a function. So it does not pass the vertical line test. All right, let's do a couple more examples of our vertical line test. All right, so let's go with, we'll go. All right, so here's our graph. All right, there's one. See if you can, why don't you guys try doing these and see if they pass the vertical line test. All right, so here are two examples. Okay, so we do the vertical line test. We'll go red again, and we're just drawing straight line. We're just drawing vertical lines and seeing, do any of them pass through the graph more than once? No, so this is a function. Function. Ooh. Sorry guys. Function. Because it passes the VLT. All right, back to this one. Draw my vertical lines. Does it pass through anywhere? No, it does not. So again, function. Okay, one more. All right, so our graph will be here. Okay, and here's what our graph looks like. All right, so we graph something and it comes out like this, and we ask, is this a function? And we do our vertical line test, and we see very quickly that this vertical line passes through here. Sorry, how do I undo that? Struggling with the whiteboard today. Get my y-axis back here. All right, so now we go back to the vertical line test, okay? And we see, right, that this passes, our vertical lines pass through at a couple different spots. 1, 2, 3, right? So we got a little dollar sign here. So no, this is not a function. And the reason being, right, is because for this input, I have 3 outputs. So when x is -1, let's say, y could be +1/2, +5, -3.5, right? So more than one output for each input on that graph. All right. The last thing that I've kind of glossed over for this lesson is just this idea of a correlation. All right. And so a correlation is simply a relationship between the data. So what is the correlation for this example? The number of minutes before I show up, before school starts, when I show up, to the number of students waiting outside. And so that we could draw this best line graph, right? To say, hey, as I get closer, or I'm sorry, the further away, the earlier I show up to school, the less students are there. Or the earlier I show up to the start of school, the more students are there, which makes sense, right? And as you guys know, the closer you show up to 8 o'clock, there are more students waiting outside the doors to get in. The earlier you show up, there are less. You show up here at 6:45, nobody's gonna be out there. You show up at 8 o'clock, right, 7:59, there's gonna be 30, 40 guys waiting out there to get in. So the correlation in this graph is that the earlier you show up to school, the less students there are. The correlation of this graph, right, the more tickets I buy, the more I'm gonna pay, okay? So that's it for lesson 98. Again, you have the two tests, right? If the soda machine function test, right? If you press Coke, you get Coke, function. If you press Coke, you get Coke or Sprite, not a function. And then the vertical line test. If you can draw a straight line through it, right, and it only hits the line or the graph in one spot, function. If it passes through two spots, like it does here, or like it does here, not there, sorry. Here, not a function. All right, fellas.